I would like to ask you to listen to our new story for our new speaker. He says that a long time ago, in a city far away, if you remember where these words come from, Jens Schauder, our next speaker, started coding on a desktop computer programmable in assembly. Uh, 30 years later, and after 20 years as a consultant, he managed to sneak into the Spring Data team. Actually, with that experience, I believe they welcomed him into the Spring Data team. But let's keep it as it says here. He sneaked in. It's okay. It's okay. Well, he works mainly with Commons, with JPA, JDBC, and when he's not bouldering, not staying with his kids, not organizing any Java user group, he's coming here to talk to us about how JPA works. Please give a warm welcome to Jens Schauder.
Thank you. Thanks for having me. So now you know me. I would like to learn a little about you. So who here is Java developer? Okay, I'm in the right room, it seems. Who does actually use JPA in his everyday work? So about half. Who does use Spring Data? Yeah, still some. So looks like I have something probably for everybody, except those that don't want to work with relational databases at all, which I can relate to. That's why they are called relational databases, right? I want to start with a little story. A long time ago, even before I started on that desktop calculator, about 40 years ago. At that time, BMX bikes were all the rage, like these small bikes that you could use to do stunts, and basically every boy in my neighborhood wanted one of those. But we didn't get one. We all had just these basic kit bikes. And so what did we do? Well, we changed them in BMX bikes by removing everything that wasn't essential to the bike, like lights, like the, what is it called, the mud guard, like the porter that you could use to carry stuff around. Everything had to go. And that looked pretty cool, at least we thought that way. And then I found this little metal thing on the back of the wheel, on the back wheel. And I thought, now that looks superfluous. And I removed it. I actually don't know how I managed to remove it because I don't think it's intended to be removed, but I did. And then I did a test drive about over a parking lot, and then I reached the end of the parking lot, but somehow I didn't stop. Instead, I got airborne, flew over a couple of bushes, and then finally came to a very sudden stop on the ground. And that was when I realized what this little piece of metal is good for. It's called in English a torque support. And it's intended, like when you hit the coaster brake, what happens is the brake basically couples this part of the axle with this part of the axle. And since your wheel is attached to this one, this will stop your wheel if this part doesn't turn. But this turn is just basically screwed to your frame of your bike, and it will very easily turn if you don't have this torque support applied. So that was a lesson learned for me. And it was, and probably is, very obvious that a biblical quote applies to me at that point. So what does that have to do with JPA, or Spring Data JPA? Well, part of my job is to watch Stack Overflow and Twitter and stuff for people having problems with Spring Data JPA. And Spring Data JPA is, as the name suggests, built on base of JPA itself. And a lot of people that are working with JPA really, that thing applies as well. I'm sure to nobody in this room, but maybe you have co-workers that need some training. So it's good you're here. This talk is filmed. You can show that to your co-workers. So I would like to start with some basics about JPA, because, as I said, Spring Data JPA builds on JPA. It doesn't try to hide it or replace it or anything. It just adds stuff to it to make it more pleasantly to work with it. So let's start with a simple example. For that, I created an entity to play around with. It's just a basic class, a person class. It has an ID attribute, it has a version, it has simple attributes like first name and gender, and it has some one-to-one and a many-to-one attribute, so we can see some effects, what happens with those. And then I start writing a simple test or application. I create a person, and I call the entity manager to persist it. For those among you that don't know JPA, the entity manager is like the most important part of the JPA API. It's the stuff that basically helps you to interact with the database. And most people think that persist does persisting. We'll see. So we persist the person, at least we call the method. And then in the next step, here, we try to find it again by passing it the class and the ID. So we get the person reloaded. And then we reload it again down here, this time by executing a query, a JPQL query. A real simple one should basically do the same as the find, selecting a person by ID. Now, everything works just as one expected, until one starts to actually look in the database. I have added some select statements in here that I query the database for directly without any use of JPA, just using the plain connection and accessing that data. And I just count the persons in the database, which should be one all the time, right? I create one person, I persist it, and then I just do querying. So these queries would return one all the time. Who does agree? Nobody. So you all know what these queries return. Any volunteers? All? So a suggestion was they return 0. And that's actually pretty close to the truth. The first query returns 0, the second query returns 0, and the last query returns 1. What the? I mean, I just executed a query, a select, and after that I suddenly have an instant in my database? What is going on here? Well, the trick is the name persist is misleading. It really should be named something like register for persisting. The entity manager has a persistent context, which is basically a cache of entities. And by invoking persist, all I'm doing is telling the entity manager, please put this entity in your cache. And when somebody tells you to flush the cache, then write it to the database. Oh, and also I want an ID for this person. So what actually happens there inside actually depends a lot on how you declare the person and what kind of database you're using. There's a little detail in here. This strategy for generating the ID, which basically tells the JPA implementation how to generate IDs. There are many options, and this one just says, well, use the default. And since I'm running this on an HQ SQL database, the default is using a sequence. And so for generating the ID, JPA doesn't have to actually persist the person. It just has to query the sequence. And it returns the ID and does nothing. But then how does find return an entity? Well, find first goes to that cache and looks like, okay, I'm looking for a person with this ID. Do I have one? Yes, I do. Great, I return that. No need to access the database at all. But in the third case, when I actually execute a query, the JPA implementation doesn't know like what is actually being queried. So what it does is it goes and says, I better flush that cache before executing the query, because otherwise I might get like stale data, which is a bad thing. So on that, actually the get single result method call, the flush happens, and we finally get our person in the database. Next example. I now coded a service because we are supposed to have like these layered architectures, and so we have to have a service, right? And in that service, I have a method setName. And that method does just one simple thing. It loads an entity, we already have seen that, how that works, and then sets the name, and then exits. But that is weird, isn't it? Because like there's a transactional in here, so the service is intended to be called without a transaction, and will create a transaction on like before the method actually gets called, and the transaction ends when the method comes back. So where does the setName go? It's a void operation, right? Actually, it isn't. It actually does store the change data in the database because the entity manager, I already told you, the entity manager keeps a cache of all the entities it basically got into contact with. And it tracks changes to these entities. So when the transaction ends, it looks in its cache and says, okay, this entity is changed. I need to flush that, and does so. So actually an update is happening there, and there's no need to call persist or merge or anything. Now, there was another method in that service. Load the person, which, if you don't remember, down on the bottom, it just does a find. Nothing special there. And now I start interacting with that person instance. What is going to happen with this code? Any proposals? Very good. 100 jelly points for the guy over here in the first row. It throws an exception, and it throws the exception in the last line. And it will be a lazy loading exception. Because what happens is, as we have seen, the service was annotated with transactional, so assuming our project is set up properly, a method starts before executing the method and ends right after it. So in this code, after the first line, we don't have a transaction anymore, which doesn't worry anybody in the second line of the code, because the address, because it's a one-to-one relationship, is already loaded. It gets loaded eagerly. If you think a little about it, it's very easy to just load one-to-one relationships with a join. That is not so easy with many-to-many relationships, because at least when you have multiple many-to-many relationships, your result set will explode and you get tons of rows, much more than you actually want. So those are retrieved lazily. And when I try to access them, the JPA implementation needs to fetch the data from the database, but it's outside of the transaction. The entity manager is basically gone, and you get an exception. So this causes a lot of fun to people. Just in this week, I had 3 discussions with other people, experienced software developers that ran in these or similar problems and suddenly didn't understand why their application wasn't working. So if you work with JPA, these are like the very basic principles that you absolutely need to understand. Unfortunately, it doesn't get made very clear in most tutorials, but it's the actually most important stuff. Otherwise, often you get tutorials where you're like, you do this, you do that, and everything works. But nobody tells you, or at least not until you run into problems, why does it work and when does it start to break? So, enough bashing about JPA. I want to actually talk about Spring Data JPA. Again, just to make sure nobody missed that, Spring Data JPA doesn't try to replace JPA. If you're working with Spring Data JPA, you still better know how JPA works, because all that Spring Data really does for you is making some tasks that you otherwise have to do very often manually a little easier. It doesn't make JPA go away. The first thing it offers for you is basic CRUD operation, create, read, update, and delete, which is actually not that much of an improvement over JPA, except maybe the API that you're actually using becomes a little nicer. Because all that you actually have to do is create an interface, typically called entity name repository, but that's totally up to you, and extending either JPA repository, as in this case, or the CRUD repository. For the stuff that I'm showing here, CRUD repository is actually sufficient. These interfaces take 2 type arguments. One is the entity this repository is responsible for, which is person, and the other one is the type of the ID this entity uses, in this case long. At this point, first clarification. Some people then go ahead and start creating repositories for every single entity in their project. That is a bad idea and not as intended. What we really intend you to do is to think about your entities as domain-driven design aggregates, like little clusters of objects and classes that belong together. Things like an order and its items. There's like really no use of an order item without the order it belongs to, right? So what you would do is you would create an order repository and would just navigate to the items from the order. So just for aggregates, we create repositories. That's actually really interesting topic in itself, and I encourage you to read up on that if this isn't totally obvious to you. But for now, and today, I want to focus on more like the plain technical features of Spring Data JPA. So what does this interface give you? Spring Data will actually create an implementation for that, and it offers CRUD functionality. You now have a save method, which is kind of similar to the persist method of the entity manager, and you have various find methods, find all the entities, find them by ID, the same for deleting stuff. You can do exists check, and you can count entities. Not that impressive, I guess. But you now have a nice API and doesn't have to fiddle around with an entity manager, which have a lot of methods that you don't really need most of the time. So what we really need is more flexibility, right? We don't just have CRUD functionality in our applications. This brings up query derivation, which is probably the best known feature of Spring Data. And it's a little like magic, I think, but it's actually just reflection. What you do is you take your interface and now add a method, like find by first name with a string argument. And if you just look at this method, it's pretty obvious what it's supposed to do, right? I mean, it's going to query the database for persons and return all those persons that have this first name. So why should you implement that? And that's exactly what Spring Data does. It implements it for you without you having to do anything for it. You can make these methods even more powerful. An example is the second one. Instead of finding stuff, you can also delete stuff or just check if it exists, or you can count stuff. And you can also use nested attributes, as in this case, in the second method, I'm looking for things that have a certain string in the city attribute, which is an attribute of the address attribute of the person. And I also specify I don't just want to look for equality, I actually want to check if the string is contained in that value. So this kind of stuff you can do and just use, and it just works. And then you get, or actually I get questions like, okay, I have this really complex query, or actually just a little bit more complex query. Like I have an AND in there and an OR, like query for this attribute and this attribute or that attribute. And how do I express that with Spring Data JPA? And while you can do this and OR, what you can't do is set parentheses. Because think about it, all that we are working with is a method declaration. We have the name of the method, we have the parameters, and we have the return type. How would you express parentheses in there? I guess you could come up with something, but I'm sure you don't want to use those method names. Even the second example I just showed you is, in my opinion, really not a good use case for derived methods. Derived methods are really intended for simple stuff, where it's just like, well, it's obvious how this method is supposed to be named and what it's supposed to be doing. For this more flexible stuff, you need more. So let's use annotated queries. Again, we go back to our repository, and this time we add a query annotation with a query inside. By default, we use JPQL, which is the query language of JPA. It does look like SQL, but it isn't SQL. And you can plug it in there straight away. You can use the arguments of your method inside the query. I actually don't have a proper example for that, just by using colon and then the parameter name in the method. So colon city could be used in the query. What is more interesting is you can use spell expressions. In this somewhat contrived example, I have a spell expression here. It starts by a colon to demark a bind parameter. That's basically the only place where spell expressions can be used. And then instead of just using a name like city here, I actually use hash curly braces, which starts or wraps a spell expression. And inside that spell expression, I can use the parameter names but I also can navigate these parameters. So if I have as an argument maybe a person or any complex object, I can navigate through all the attributes. I can do checks or a ternary operator or any stuff in there. I can even register extensions for these spell expressions so that I can use my own functions or methods inside that spell expression. I didn't bring an example for that, but it should be easy to find. And if you don't find an example, just ping me. We'll fix that. So this is already really nice and gets even nicer with pagination, which is something you need a lot if you do like web applications and don't do this awful infinite scrolling thing. You need pagination. And that's really, really easy. You just take a method as you have and then just plop a pageable argument in there, which tells Spring Data, hey, I want this paginated. And if you also return a page of person instead of a list of person, which you can still do, you get a full page object, which is basically a list plus a couple of attributes like a reference to next pageable, so you can easily query the next page, and also the total number of elements. For this total number of elements, like not just in this page, but like in the whole search result, we need to execute a count query. This is kind of obvious and normally not very expensive, but sometimes you don't need that and don't want that. In this case, you can return just slice or list, which doesn't have this attribute, so we don't execute that query. So that gets already rather nice, and you can already do quite some stuff with that. Actually, without really interfacing with JPA. So what else? Next thing you should consider are projections. If you model your domain objects, your persons, your customers, your orders, or whatever you deal with, these domain objects tend to become rather complex. There are people that are arguing that is a design mistake in the first place. Again, might want to read up on domain-driven design about that, but most applications have these one way or the other. And sometimes you don't need all that stuff. You maybe have an entity with like 20 attributes, but you really only need 3. And this is the place where projections help. Again, with a method like this one, there's still the pageable in there. Well, it works with pageable or without. The important part is that I changed the return type to something of simple person now. So I don't return persons, I return simple persons. And simple persons aren't persons with a low IQ. Simple persons are person entities with fewer attributes, like maybe only the first name and the gender, or whatever you need in your application. And what Spring Data will do in these cases is it will query for persons, but then just fill these attributes. And it actually tries to limit to query only those attributes that you actually need. This part, though, is really limited because if you look in the JPA specification, there are ways to specify what you want to get queried, but these are just hints. So the implementation isn't bound to actually honor these hints. And in many cases, they don't. So although Spring Data might say, hey, just query this and this attribute, the JPA implementation might still go, I don't care what you want, I query everything. So it doesn't, like the the query optimization there doesn't work always as one intended. And also, if you use the feature on this third attribute, where I create a new attribute in this interface, which doesn't exist like that in the entity. The entity had an address, which happened to have the same name, but it was actually of type address. This is a string attribute, so it's something completely different. And it actually gets populated by the spell expression in the annotation above. Again, we have this hash curly braces to demark the spell expression, and then we can use target as a synonym for like the underlying person object, and just navigate in there and combine stuff or filter stuff or whatever you want to do. If you use those, Spring Data doesn't really know which attributes you need to know. So it basically queries complete person objects. So from a performance, if you want to use projections to optimize performance, you should shy away from these attributes. If you just want to use projections for having a nice API for the developers using it, go ahead and use it. It should work fine. Projections are really a special case of conversions, right? Our query normally returns a person, but we decide we want a simple person. And what Spring Data also offers is to various return types, like not the entity, but the stuff around it. You already have seen that we can return pages, slices, lists. We can also return iterables, collections, streams, which are basically all the same, right? If you just squint a little. You can also choose, instead of returning a simple entity, if you have something like find by ID, or where you want just one element back, you can either return an entity and get null if nothing gets found, or you can return an optional and get an empty optional if nothing gets found. And if you use something like waiver, formerly known as Java slang, you can use their class, which is, I think, option, or seek, which is a sequence, basically a list, instead. And we will do the conversion for you. But again, we are right now pretty flexible with our queries, right? We can do a lot of stuff. But I think sometimes it has become still more powerful, still more flexible. And the next step would be query by example. Like every application that does CRUD has basically a search form. And depending on what kind of style you use, you either have one big search box, or you might have like one field for every attribute where you can, the user can plug in values to filter the results. And this can't really easily be done with like an annotated query, right? You need to decide dynamically what to include in the where clause of the query. And this is exactly what query by example is good for. You start by populating an entity with just the values that you want to filter for. Like in this case, the country in the address over here, and the gender. And then you create an example from that. And then you can ask your repository, please find me all the entities that match this example. But often, this queries for equality, so it checks is the state the same and is gender the same. But sometimes maybe you want that like when any of the attributes matches. Or you don't want to use equality for comparison, you want to ignore the case, or you want to use like, where it's like contained in the string. And all this kind of stuff you can do with examples by configuring an example matcher, which with matching all or matching any, and you have all kinds of methods available to fine-tune that. So that is already pretty flexible and solves problems in many cases and is sufficient. But there's one typical use case where this fails, and this is typically with dates. The need appears to use ranges. Like you very often want to query something like, okay, I'm looking for people that are born in the 70s, so after January 1st of 1970 and before the 1st of 1980 or something. But you can't do that because the example is based on an entity, and that can just have one date, but now you need to plug in 2 dates. And you still can do that with Spring Data JPA. And the keyword here is specifications, which again is a term from domain-driven design, which is basically, I write a specification that describes what I'm looking for. In order for that to work, we need to extend our interfaces, or our repository interface, with JPA specification executor. Which gives us this find all method and a couple of variants, stuff with like pageable and a way to order stuff. And the key part is that we pass in a specification, which in this case we create in this method, and this specification is really just a part of the criteria API of JPA. So now we are actually with both feet deep in the mud of JPA, if we like it or not. We get passed in a couple of objects, which you'll often need for then creating a predicate, which is the root, which is basically the class that you're querying for, the actual query, and a criteria builder, which is basically a factory for all kinds of conditions. And the bad part about this is this code. I don't know how you think about that. I don't consider that really very readable. It's great because I can make it completely dynamically. So, for example, instead of putting in just a single string, I could use a map and then iterate through the map and decide on what is in my map to what clauses I actually add to my predicate, but it's really not that readable. So there's an alternative for that, which is Query DSL. Query DSL in itself is a completely independent project, has nothing to do with Spring or Spring Data. It's just an alternative for the criteria API, or at least the Query DSL for JPA part. It exists for a lot of other database APIs. And we just offer an integration, which is basically the same thing as before, but this time we use Query DSL. We need to include a different interface to extend from the Query DSL predicate executor. You know, Spring is famous for its names. And again, we get a find all method. But now the implementation looks much nicer. This Q customer is actually a typo. It should be Q person. Actually, the first part is a little messed up. It should be qperson.address.city. These Q classes get generated by Query DSL, so you need a Maven plugin, or depending on what build tool you use, to create those, and then you get a nice clean DSL to formulate queries like that. So that is really nice if you need this kind of stuff. So, suddenly break. Actually, let me this one for a moment. So I think you saw you can do a lot of stuff with Spring Data JPA without really touching JPA. This goes so far that actually, like I mentioned in the beginning, that 3 times alone in this week, I help people with their JPA problems. One of those persons, although they were already for quite some time working on this project and using Spring Data JPA very heavily, when I told him to well, could you inject an entity manager in there so in order to debug a couple of things, he was like, what the heck is an entity manager? Which I found a little scary. And so this can happen. You can get pretty far just with Spring Data JPA. But Spring Data JPA is there to help you. If you have something that works with JPA directly, nicely, and you don't find a nice way to do that the Spring Data JPA way, go ahead and actually use JPA. Inject yourself an entity manager and use that. There's actually another feature that I thought, or that I can't really cover properly, which are custom methods, which is basically the normal way to do things. You declare a method in an interface, whatever you want, and then you actually provide an implementation. Yeah, how cool is that? That is actually a very important, not very sexy, but very important part or feature of Spring Data. You always have the access to the underlying persistent technology. And it's perfectly fine to use that. But there's this thing about JPA. Could I have again hands for those that use JPA on a regular basis? Okay, keep the hands up there. And who of you actually likes JPA? Okay, there are not that many hands, and they're like something like a little. Okay, so some really like it, and that's okay. But there are a lot of people that have problems with JPA because due to these things I mentioned in the beginning, that JPA sometimes tend to behave in a way that is not obvious. And it can get really difficult to understand what is really going on. And if you're in that camp, there's the alternative that you already saw, which is Spring Data JDBC. Spring Data has many modules apart from Spring Data JPA for all kinds of other databases, normally NoSQL databases. There's a Spring Data MongoDB, Cassandra, Redis, LDAP, Key Value, Neo4j, all kinds of stuff. But most of us are, for good or for worse, are bound to a relational database. And for a long time, the only option there was use Spring Data JPA or don't use it at all. And now, for about almost a year, we have another option, which is Spring Data JDBC, which tries to do the same stuff as Spring Data JPA for JDBC, making this interaction easily. It's by far not as feature complete as Spring Data JPA. Very clear, Spring Data JPA is about, I think, 12 years old by now, or 10 or something. Spring Data JDBC is less than a year old. Spring Data JPA was worked on at least part of the time by multiple persons. Spring Data JDBC was mostly done by me. And well, it was told in the beginning, I just snuck in the Spring Data team a little more than 2 years ago. And I actually had very little knowledge how Spring Data worked internally. So apart from doing Spring Data JDBC, I also had to learn Spring Data itself and do support for Spring Data JPA. So there's a lot of stuff that is still missing. But there's one thing I can guarantee you. It's conceptually way, way easier to understand than JPA. I can't really go into details today, but if you're interested in that, just Google it. By now you will find it without a problem, or just talk to me after the talk. I'm happy to tell you what we did with Spring Data JDBC and where that journey is taking us. Having said that, there are actually cases when things break. I mean, Spring Data JPA obviously doesn't contain any bugs, right? All these issues in Jira are just fake, I guess. But maybe the underlying implementation has a bug. Or maybe if you didn't write the code, but a coworker, he or she might have introduced a bug. And it's just your task to fix it, right? You don't put bugs in your code. Who would do that? So what can or what should you do when things break? When the results you're getting don't look like you expect them to be, or if you actually get an exception. One thing that really helps to debug problems is to first understand where is the problem actually coming from. If you go to Stack Overflow and ask a question, as many people unfortunately do, like, okay, I'm using this JavaScript framework and this web server, and I use Spring Data REST, I think, and Spring Boot, and Spring Data JPA, and Hibernate, and database, and something goes wrong. Most people that look into that, like most of these projects, have people that watch Stack Overflow and are willing to help. But I see a question like that, I'm not very motivated to look at that for half an hour just to find out it's actually a problem with the JavaScript framework that I can't help with. So it's in your interest to find out what is actually failing. Get in the habit, for just your own sake, to create small test cases. We all write test cases for our code, right? That sets up a database. If you don't know how to set up a database for your test, Google test containers. It's really great, and it's much better, at least for the non-trivial stuff, than an in-memory database, because you can use your actual database, your Oracle or Postgres or MySQL database, and test locally against that with almost no effort on your side. And then look at the stack trace. Which library is actually throwing the exception? And that's like on the very bottom of the stack trace. Not on the top. On the top, you almost, like if you use Spring, you almost always will see a Spring exception, because Spring does try to like analyze the exception that is thrown on below and try to make sense out of it and give you like a general exception that in general terms tells you what is going wrong. But down on the bottom, you see like the first line that actually threw an exception. And if that line is from Hibernate, you probably have a problem with Hibernate. It's not guaranteed. It still might be that Spring Data JPA pushed something to Hibernate that is bogus. But, well, it gives you a hint. If that line is Spring Data JPA, it's probably the other way around. Also, whatever you try to do with the Spring Data JPA, and if it doesn't work, try to do it with plain JPA. Again, I told you, you still have to know JPA. There's no way around that. So if you do query derivation and you suddenly get an exception, try to create the query that you want to execute just with JPA. Does it work? Then probably something is wrong on the generation side, so maybe you picked the wrong name or something, or actually found a bug in Spring Data JPA. Or doesn't that work? Then maybe your mapping is wrong, which is actually a very common reason. So by this kind of stuff, try to find out what is actually going wrong. And if you go with that, like very often, it will actually show you what is going wrong in so much detail that you can fix it yourself. But if you go with that to Stack Overflow and ask a question. And again, I know a lot of developers pondering problems for days and days and don't even look at the internet, let alone ask a question on Stack Overflow. Get in the habit to ask questions. Yes, Stack Overflow can be sometimes quite intimidating when you start there, but really these people try to help. And if you ask good questions, you tend to get good answers. Anyway, in the end, ask question on Stack Overflow, and if you actually think something is broken, raise issues on the libraries involved, and we will try to fix that. In this talk, I obviously could just hint at the different features of JPA. So if you want to get into more details, I have a couple more references for you to have. Nobody has to, well, you can photograph it, but the slides will get handed out anyway. And if you want to know more about who's this weird guy talking, that's me. I'm Schauder. I'm working on Spring Data JPA and Spring Data JDBC. If you want to reach me, you can write an email to the address on the left or to the Twitter handle on the right. And if you want to talk about something else, but software development, you can talk about kids or games or fitness and all kinds of stuff. Of course, you can also tell me about you. I'll be listening, and I'm curious. So I'll be here for today, and just another note for the image, which I was allowed to use. Important today, I guess. And that's it, and I'm open for questions. And if somebody doesn't believe the example with the count, well, I can demonstrate that, but I hope you believe me. Thank you.
Questions, please. One question.
Yes, I have a question related query by example. Are there some key points or some hits when this can be used without having performance issues? Since this type of queries allows you to add a lot of conditions in the query.
Well, Spring Data JPA really doesn't help with that because the performance of such a query that we basically create for you depends on how your database looks like. So if you have huge amounts of data and have queries like that actually use things like, which basically makes it impossible for the database to use an index in most cases, your query will perform badly. But this is really a question for database tuning. And that's another thing that one should realize when working with JPA. You still have to know your database in SQL. And if you have performance problems, a good approach is often to require certain fields. Like don't allow your user to search for everything and anything, but put in requirements like you have to specify this or you have to specify that, and then put an index on these fields, and thereby say, okay, I at least can limit the result set to some extent, so the rest won't be so heavy on the database. I guess that's all I can recommend for that.
I have also 3 questions for you coming through my connector. Thank you guys for using it. So the first is, can you provide us with some popular problems encountered throughout your experience related to data model design with JPA, and also some best practices? Thank you. From George. Thank you, George.
That's actually an interesting point. There's like, I don't know who knows Vladimir Alkir. I hope I didn't butcher his name too badly, who is a really awesome Hibernate expert. and he really knows Hibernate. And one interesting part is if you look at his blog posts regarding relationships, he actually recommends to use bidirectional relationships all the time. Because Hibernate, for a reason that I honestly can't explain right now, can optimize these much better than one-directional relationships. So that's the point of view of somebody caring foremost about performance, which is reasonable. But we at Spring Data, while we certainly understand the importance of performance, our primary design goal or design idea is domain-driven design and just a clean design of your domain. And in that sense, a bidirectional relationship is really a really bad idea. Our approach, and actually the approach in Spring, realized in Spring Data JDBC, is you should never ever have a bidirectional relationship, because you should think in aggregates. And aggregates, like these clusters of classes, they should have an aggregate root, which is like the one class that represents the whole. Like in the example of order and order item, you should have an order item, and you might pretty obviously want to navigate from the order to the order item, right? But you will never ever start with an order item. Why would you do that? Why would you like load an order item by something and then navigate to its order? That, from a business point of view, that doesn't really make much sense. So we actually recommend to not use bidirectional relationships, which basically is just an example. These generic advices, if anybody tells you, like, do it always this way or do it always that way, these advices are wrong. And that's not really what we're doing. We are saying, like, we recommend this as like a default approach, and then if you have problems, do something else. If some advice like this would exist, people would build that into the tools, and that doesn't work. So I can't really. And if I had like enough examples that I could talk about, I would write a book. But Vlad actually did that for Hibernate, and I recommend his book, which I think is really awesome. I have a signed copy at home, but I didn't find time to actually read it, but I'm pretty sure it's really good.
Second question, please, from Mihai Grigoraș. Is there an easy way to use pagination with native queries? If yes, can we have an example?
Yes, I'll just do it. So first, I think I didn't mention that in the query annotation, I mentioned you use by default JPQL. You can also use a native query, which is SQL. And all you have to do is provide another attribute in the query, which is native query equals true. And then we know, and we'll tell JPA, hey, this is SQL, you don't have to convert that. And if you want to use pagination with that, just add a pageable attribute, and it will work. If you use the current version or a not too old version of Spring Data JPA, there has been a bug a long time, and there was like, if you search for that, you find a lot of weird workarounds, like putting in the query something with hash pageable. Don't do that. That was a workaround that worked sometimes with a really old version of Spring Data JPA. Just make sure you have a recent version of Spring Data JPA and just add a pageable attribute or argument and make the return type a page of your entity, and it will work. And if it doesn't, please open an issue on our Jira. That would be a bug.
And third question, coming from Miklos, thank you very much. Can I use Spring Data JPA and Spring Data JDBC together?
yes, you can. You really shouldn't use it for like the same tables, because both have very different ways to handle stuff. And if Spring Data JDBC does its thing while JPA does its thing on the same tables, you probably end up with lost data. So don't do that. But what you can do is like, well, for these entities, I want to use JPA, and for these entities, I want to use Spring Data JDBC. That works perfectly. You probably want to look up using multiple data sources with Spring Data, because the approach is basically the same. Like to enable or to activate Spring Data, you add to your Spring configuration or your Spring Boot application and enable JPA repositories, or for JDBCs, enable JDBC repositories. And you can then specify which data source to use and also which packages to apply this to. By default, we use just everything below, on or below where this annotation is.
My fault.
And but we can specify like, do this for this package with Spring Data JDBC and for this package with JPA, and that should work just fine. Although I have to admit I never tried it, but I don't see a reason why it shouldn't work.
Hi, Alberto here. About working with store procedures, which is better, Spring Data JPA or Spring Data JDBC? And I'm talking about a very strange use case. I have a database that
You already mentioned that. You mentioned store procedures.
Yes, rewrites the store procedure dynamically. And I want that my code doesn't change, to be dynamically mapping to the new signature of the store procedure.
Okay, it's actually really easy to answer your first question. Spring Data JDBC doesn't have support for stored procedures yet. The stored procedures aren't the you can interface to stored procedures with Spring Data JPA, but I have to admit there are a lot of bugs in there, and it's hard to debug it because basically every database does stored procedures a little different. So yeah, stored procedures are a pain point. I have to tackle that at some time. I'm just like pushing that away. But I know about that. I'm sorry.
Thank you very much, Jens. Thank you very much, everybody. Big applause for Jens, please.
Thank you.